In example 4, you're dealing with a different format of a quadratic function. Notice this is not looking like the vertex form. And although there are ways to convert this to the vertex form, either by completing the square, or as you're going to see, being able to interpret certain things about this, it's a little easier to convert it into vertex form. You can actually get a lot of the same information from this standard form. A standard form for a quadratic function is going to have f of x equals ax squared plus bx plus c. You're going to arrange the three terms in your trinomial from highest power of x down to the constant. So basically for this, when you have a situation where it's in this kind of format, you can find the axis of symmetry by doing negative b over 2a, where b, of course, is the coefficient on the x term, a is the coefficient on the x squared term. Since the axis of symmetry is also where the vertex is located, it's located somewhere along that, the vertex is going to have the x-coordinate at the axis of symmetry, and you would find the y-coordinate by simply substituting that value into the function and evaluating it. So that's what this terminology here means. So for this circumstance here, I'll make it a little bigger so it's easier to see. You can see that a is 4, b is a negative 24, c is 5. So the axis of symmetry is going to be at x equals negative 24. This negative is part of the original formula for this. The negative 24 is the actual value of b, over 2 times 4, where 4 is the a value. 2 times 4 is 8. Negative 24 divided by 8 is negative 3, but you're doing the negative of the negative 3, which is going to give you a positive 3. So you know that the x-coordinate of the vertex is also going to be at 3. To find the y-coordinate, you're simply going to take that value of 3 and substitute it into this formula. So you're going to do f of 3, and if you do 4 times 3 squared minus 24 times 3 plus 5, you get a negative 31. So the vertex is at 3, negative 31. Well, since you know what the vertex is, and the a value would be the same for this as it would in the vertex form, which is the a times x minus h squared plus k, where h and k are the coordinates of the vertex. And this a value, as I said, is going to be the same as this a value here. When you substitute it into this formula, you're still going to have the 4. You're going to have the minus 3, and you're going to have a negative 31. The minus is already given to you because that's what k was. And that's how you can convert to vertex form once you determine what the vertex of something in standard form is. You don't necessarily have to complete the square, although that is a method that you could possibly use. For this, you have that the daily profit, F, in dollars, of a hot pretzel stand is given by the function f of x equals negative 1,875x squared plus 4,500x minus 2,400, where x is the price for each pretzel. You're asked 2 questions here. At what price should each pretzel be in order to maximize the daily profit, and what is the maximum daily profit possible? So, basically, if you're looking for a maximum on this, and you can see that the a value here is negative, which means this should be concave down and have a maximum, that you're looking for where the vertex is. So when you're looking for the value of x that's going to maximize the daily profit, or the pretzel price, well, that's what x stands for. So let's find the axis of symmetry, and that's going to give us that x value. So here's your a value of negative 1,875. Here's your b value of 4,500. So putting those values into that formula of negative b over 2a, and when you calculate all of this out, you get that x equals 1.2. That's $1.2. So you're going to have $1.20 be the price of the pretzel that's going to maximize the daily profit. Of course, what is that maximum daily profit? Well, you're going to put that 1.2 into f of x, and substitute in for the x, and when you do that, it comes out to be 300. So $300 is the maximum daily profit under these conditions. And so that is the end of this example, and that is the end of this video. If you have any additional questions, please make sure to bring them up during class.